Okay, let's have a look at a 3D example for Pythagoras. So, question here involves a rectangular prism. Determine the length of AG in this rectangular prism to 2 decimal places. Now, what we've got to find then, okay, if I just draw a straight line from A down to G. Okay, so I need to find that length there, all right? Now, what we've got here is quite a number of right-angled triangles, and we have to actually find eventually the length AG. So to find AG, and if I just change colour, we're going to also need the length EG, which is down there, okay? And that actually forms a right-angled triangle here called A, E, and G. Now the difficulty with this work is that we're taking things from 3 dimensions and putting them into 2. So that triangle there, okay, E members on the ground, A, E, G, the way we look at it in a 3D diagram doesn't look very right angled, but as soon as you extract it and then take it out into 2D, like that, okay, it might make a little bit more sense. So let's have a look. Let's do a little right angled triangle marker there. So I'm going to label it A, E, and G. And remember, this question is asking for the length AG. Now, we look here and we've got 5 centimetres for BF, okay? So the height will be 5 centimetres for this whole figure. So that length there, AE, is also 5. So I can put that 5 there as well. The problem is to be able to find AG, which is the hypotenuse, okay, that's the hypotenuse, I need to actually find out another side. I can only work out the hypotenuse, AG, which is what the question's asking, there it is, if I have 2 out of the 3 sides. I may have only got 1. So I have to find out length EG, down the bottom there, that red line. And to do that, I'm going to use this triangle on the bottom. Okay, actually, I'll just use my straight line tool again. That triangle on the bottom, here and here. Now, once again, because that's in 3D, that doesn't look like a right angled triangle. But if I draw it here separately, like that, okay, so that's E. Oops. That's E. That's H. And that's G. Okay, to be able to work out the hypotenuse, I need to find out EG. So I need to find out this hypotenuse here. All right, and I know EH, okay, because it's 9 centimetres. Okay, so if you look there, that's 9. So EH must be 9 as well. There. So EH is 9. And GH is 10. Okay, so that's 10. So that means I can use Pythagoras' theorem once I've got 2 sides to work out the hypotenuse. Okay, remember we called the hypotenuse C. There it is. So C squared equals A squared plus B squared. C squared equals, now we'll call A equaling 9 and B equaling 10. So we'll equal 9 squared plus 10 squared. So C squared equals 9 squared, which is 81, plus 10 squared, which is 100, so 181. C will be the square root of 181. Let's see what that is. Calculator out here. So 181, and the square root is 13.45. So C is 13.45. So my hypotenuse here now is 13.45. So that is EG. Now that EG there, the red EG, is the same EG that's here in this triangle here. Remember, I'm trying to find AG, and I couldn't find AG because I didn't have EG. I've been able to find out EG in a separate triangle. So that EG is 13.45. So I can now work out the distance AG. Once again, it's Pythagoras because now we're looking at C. So C squared equals 5 squared plus 13.45 squared. Okay, so C squared equals, so we've got 13.45 squared plus 5 squared, and then we get the square root of that in a minute. So C squared is 205.90. C is the square root of 205.90. That's 14.35. So that's the length of AG. So just repeating, to work out AG, we use the right angled triangle A to E to G, the green triangle. We've only got one length of that, which is 5. So we have to find out EG to find AG. The triangle at the bottom, the yellow and red triangle, enables us to find out EG because we've got 9 and 10. Once we've found out EG on the bottom triangle, we can use that to work out AG on the upper triangle here. Hope that is of benefit. Bye for now.